now, so this is all going to be explanations and stuff that you guys can access later, because all of these meetings I'll be posting on my website. So what I'm going to do is create 2 examples where we're going to be solving for the side of a right triangle. Sorry. Unless you have a specific question from the lessons that you'd like to ask, Brooke.
I don't have any questions right now.
Okay.
Hey, Brooke? Brooke? Can you hear me, Brooke?
Yes.
Can I suggest that you grab that notebook that we started in and you go to the next clean page and give it a title, like examples with Mr. Sunderland? And then I'm just going to listen in.
And again, Brooke, I'm so proud of you for getting up and making sure that you're here. I appreciate that. I think that this will be a little bit helpful. So what I've got here on my little whiteboard are 2 examples. I'll walk through the first one with you, and then I'll have you do the second one. And then we can go over how the second one went in a minute. But as I mentioned in those lessons, and it sounds like Ms. Johns has been working with you a little bit on that, which is awesome. Let's look at this first one. A great way to start these types of problems are, based on where the angle is, labeling your sides, right? I've got these 3 functions, sine, cosine, and tangent, and knowing which one to use is pretty tough unless you know which sides that you have, okay? So x is across from the angle, so I'm going to call x the opposite side. 7 is next to it, so we call it the adjacent side. Remember, in trigonometry, we just use this fancy word adjacent. Adjacent simply means next to, okay? So I've got opposite and adjacent. So I have to look at these 3 things, sine, cosine, or tangent, and figure out which one utilizes the opposite and adjacent side. Well, TOA has OA, so we're going to use tangent. So I'm going to go ahead and set up my ratio and say tan theta equals opposite over adjacent. And now you just start plugging in all the stuff you know. Remember, theta is kind of a weird thing, but it's just a Greek letter that we typically use for an angle in math. My angle is 58 degrees, so I'm going to go tan of 58 equals my opposite side, x, over my adjacent side, 7. And now just about the geometry is over with. Now it's an algebra problem, and a pretty easy one at that. X is being divided by 7, so my one step to get x by itself is to undo divided by 7, and that's to multiply by 7. So I've got 7 tan 58. I go ahead and put that into my calculator. Where is my calculator? There we go. And depending on the calculator you use, this step can be kind of different. How do you feel about getting these answers with your calculator, Brooke? Have you and Ms. Johns gone through that at all?
Yeah, I think so, yeah.
Okay. The key thing where a lot of mistakes occur is people don't know how to get their calculator in the right mode. We always want to be in degree mode, typically when we're doing right triangles. So I hit 7 tan 58, and I'm getting, on my calculator, 11.20. Okay, so we're going to do this next one. Can you read that angle there? That's a 71 degrees. Why don't you work the next solution? See if you can solve for x in this next example. I'll give you a couple minutes here. So when we're labeling our sides, 10 is the one next to 71. So it's going to be the adjacent. A side x, and this is where a lot of students make a mistake sometimes, is they forget that x, the side across from the right angle, is always the hypotenuse. Okay? So, looking at this, I've got adjacent in hypotenuse. That means I have to be using cosine. The cosine of my angle equals the adjacent over the hypotenuse. Now we've got a slight dilemma here because x, is on the denominator. To get, as I said in those lessons, to get x by itself, we're actually able to just swap this whole left side and x. So I make it x equals 10 divided by cosine of 71. 10 divided by cosine of 71 is something that I can put directly into the calculator. I type that in, and I get a pretty big number here. I get 30.72.
You think it's a joke? What kind of dollars running around?
How we doing?
$20 for Trumpy Bear? That should be free.
Okay, so I'm gonna wipe the board clean, so to speak, here. And I'll do a couple where we're doing inverse trig. That was kind of the new thing in this most recent lesson. And it's going to allow us to solve for an angle in a right triangle if we know two of the sides. All right. We'll just go with a similar setup with these two triangles, but I will call this one theta. And these will be the two examples that we're going to do here, okay? Now, the way these types of problems work is we're going to start just like we started the other ones, meaning I'm going to label the sides, in terms of the language, opposite, hypotenuse, and adjacent. So if you position yourself at theta, this side 10 is across from theta, so we call it the opposite side. 12 is across from my 90-degree angle. 12 is the long side in the right triangle, so it's the hypotenuse, okay? Opposite and hypotenuse, I look at my three functions, SO, CA, TOA, which one uses O and H? Sine does. So I start by just putting sine theta equals opposite over hypotenuse. And now we're going to plug in everything we know. I don't know what theta is, so this left side is going to remain sine theta. But I do know that the opposite side is 10, and I do know that the hypotenuse is 12. And again, like the other ones, essentially the geometry is over. It's now an algebra problem, but there's this weird step here. To go from sine theta to theta, we use inverse sine. Now, just like if you were solving, say, this equation. I've got 3 times x equals 12. How do I get x by itself? I have to do the inverse of 3 times x, which is divided by 3, divided by 3. Same thing happens here. We just tend to not show sine inverse on the left. We tend to just say, to go from sine theta to theta, is I take the inverse sine of the right side here. That's what that -1 means. It just means inverse sine instead of regular sine. And on almost every calculator I've ever seen, inverse sine or inverse cosine or inverse tangent, all of those are located above sine, cosine, and tangent. So usually in most calculators, you just have to hit second or shift. So looking at my calculator here, I'm not sure how much that helps. There it is. I hit second sine, and there's my sine inverse there. I'm just going to do second sine of 10 over 12. Hit enter, and on my calculator, I got 56.44 degrees. All righty. So I'll leave this up here. There's the next triangle. You've got theta, 4, and 5. Writing all this down, see if you can solve for theta. Let me shut some of these blinds here. I'm getting a little bit of a glare coming at me. All right, so in starting the problem, like we have been, positioning myself at theta, 4 is the opposite side. And some teachers even have kids just put O and A and H. The problem I always have with the letter O is we'll think it's 0, so, and this theta looks like a 0. So to just write down OPP makes it a little more specific and less likely for us to confuse it with something. So I've got 4 is my opposite side, 5 is my adjacent side. Which one of these 3 uses opposite and adjacent? That would be tan. So tan theta equals opposite. I can't reach. Should have Brought my markers from school home. Tan theta equals opposite over adjacent. Let's plug in what we know. The opposite side is 4. The adjacent side is 5. Now I just need to do the inverse tangent to solve for the angle. So theta will be the inverse tangent of 4 over 5. Now the nice thing about a lot of trig is we can make a pretty logical guess about what that angle would be. What I'm saying is if both of these sides were 5, go back to our special right triangles, the 45, 45, 90 things. If both of these were 5, then I would know that theta is 45 degrees. But they're not both 5. My opposite side's a little bit less than the adjacent side, which means theta should end up being a little bit less than 45 degrees. So we'll type in tan inverse of 4 over 5. And like we suspected, a little under 45. I got 38.66 degrees. Nice. And again, this little lesson here will be recorded and posted on our website should you want to go back or if you missed something this morning. Speaking of special right triangles, maybe I will take a minute to do a couple examples with special right triangles. Okay, so I'm going to erase the board here. And, man, I think I'm going to pull out all the stops here. I think we're going to do 3 45, 45, 90s and 3 30, 60, 90s. Okay. So, we'll start with this guy. I see that my 3 angles are 45, 45, and 90. So go into my shortcuts, okay, and hopefully you've got your notes handy that show all the formulas or equations from our shortcuts. But the shortcuts for 45, 45, 90s are simply hypotenuse equals leg times root 2. Okay. So what do I have here? I've got the leg. I plug it in to my equation, which means, well, if one leg is 4, the other leg is 4, and my hypotenuse is 4 root 2. Here I've got a similar situation. I've got 2 equal sides and a 90 degree, which means it has to be a 45, 45, 90. But I've been given my hypotenuse, so I plug in 10 into this equation, and I get 10. Let's call these guys x equals x times root 2. Divide by root 2, divide by root 2, and I get this weird thing, 10 over root 2. Can't have that, so we have to turn it into 10 root 2 over 2, which gives us 5 root 2. Okay, my board's getting a little crazy here, so I'm going to erase it. My last one looks like it's going to be harder than the others. But if you've got a 45, oh, but I don't know that angle. Using triangle sum, it's got to be 45 degrees. 45, 45, 90. My hypotenuse is 13 root 2. That just means the legs had to be 13. It's 13 times root 2 equals 13 root 2. Let's do a couple 30, 60, 90s, and we'll call it good. All right. I'll put our reminder equations at the top here. Hypotenuse equals short leg times 2. Actually, I'm going to write it differently. Okay. Here were our two equations with 30, 60, 90s. Write those down if you don't have your notes handy. And I'll give us 3 questions to practice. All right. I'll hold these up here. Give you and anyone else watching this video at a later time to solve these. If you're watching this video at a later time, you can go ahead and pause it and try solving these. But we've got 3 30, 60, 90 triangles. And there are my shortcuts. I'll get a little bit further away. And we can practice these problems. You can hear my kid in the distance screaming about Mickey Mouse. The little things in life. But go ahead and start filling in some answers here. So, for special right triangles, we first want to identify, is it a special right triangle? And I've got 60, 90, it means this has to be 30. Yep, it's the 60, 30, 60, 90 example. So which of the 3 sides do I have? Do I have the short leg, the long leg, or the hypotenuse? In this case, I've got my short leg. So what this first shortcut means is I can just multiply the short leg by 2 to get the hypotenuse. And this second equation means I can just multiply the short leg by root 3 to get the long leg. I write it as 5 root 3, and I'm good to go. I'm done. The next one, I've got a 90, a 30. It's got to be a 30, 60, 90 because of triangle sum. So the next thing we figure out, which of the 3 sides do I have? In this case, I've got the hypotenuse. This top equation means if the hypotenuse is 2 times the short leg and the hypotenuse is 22, 2 times what number equals 22? 11. So 11 is my short leg, and 11 root 3 is my long leg. My last example, I've got a 60 and 90, which means we've got 30 again, so 30, 60, 90. Which of the three sides was I given here? I was given the long leg. So that means that the long leg, 10 root 3, equals the short leg times root 3. So check it out. Let's say I call the short leg x. If I plug in my long leg into this equation and my short leg into this equation, then I get 10 root 3 equals x times root 3. Dividing both sides by root 3 just means that my short leg is 10 and my hypotenuse is 20. Hopefully that's what you got, or that clears some things up. So, Brooke, you're the lone participant here. Any specific questions, whether it's from these types of problems or from the 2 lessons that we've done so far? Any questions I can answer for you?
No, not right now.
I have, with a couple kids so far, helped people out with some technological things. They've struggled on their calculator to get the right answer based on mode or depending on the calculator they have. So if you do stumble across something, know that you can send me an email. I bet Ms. Johns is available via email should you have any questions for her. So don't hesitate to reach out to us. I'm not sitting on my computer all day, but I am, however, checking my email regularly. So we will get back to you should you have any questions. Sound good?
Yes.
Hey,
Awesome.
Brooke, will you hang out a minute and talk with me when you and Mr. Sunderland are done?
Sure.
Well, I started the meeting, so you guys may need to touch base yourselves.
Do you have to close out your meeting, Mr. Sunderland?
I do.
I only need about 5 minutes with Brooke.
I tell you what, yeah, I'll stop the recording
Okay, great.
and leave it on here.
And just leave us, yeah. Are you all done with Brooke, Mr. Sunderland?
Yeah, I think so. Brooke, you good?
Yes. Yeah, I am. Yeah.
The
Okay.
rest of you watching this later, take care. That's the end of our recording.